What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exam. So let's get into it. In this video, you are going to learn about comparing and contrasting the security implications of different architecture models, focusing on a range of considerations that influence architectural decisions such as availability, resilience, cost, responsiveness, scalability, ease of deployment, risk transference, ease of recovery, patch availability, the inability to patch, power, and compute. All right, so let's start by quickly defining architecture models. So in IT security, an architecture model is essentially a blueprint or design structure of how systems and their components interconnect and work together. Common models include on-premises, cloud, hybrid, distributed, and microserver architectures. And each of these models comes with its own set of considerations, especially when it comes to security. So in the next few minutes, we're going to explore key factors that can make or break your architecture model in terms of security. All right, so let's talk about availability. So availability, this is all about ensuring that systems and data are accessible whenever needed. A system with high availability is designed to be operational 24/7 with minimal downtime. In terms of security, availability is critical because cyber attacks like distributed denial of service attacks can render systems unavailable. So for example, cloud-based architectures generally offer better availability through redundancy and load balancing, while on-premises systems may have a single point of failure unless designed for high availability with backup systems. All right, next we have resilience. So this is the ability of an architecture to recover from failures or disruptions. So think of resilience as a system's toughness or the ability to bounce back quickly after being hit. In security terms, a resilient system can detect issues, contain them, and recover rapidly. In different models, they can handle resilience differently. Cloud-based architectures, for example, often come with built-in disaster recovery options. However, in on-premises models, you need to design resilience into your systems through backups, failover clusters, or off-site storage. All right, next we have cost. So one of the key factors in choosing an architecture is cost, and this includes initial setup costs, maintenance, licensing fees, and unexpected security costs. Cloud-based models generally have lower initial costs, but could have higher recurring costs depending on usage. In contrast, on-premises systems require substantial upfront investment in hardware and software, but offer more control over long-term costs. And from a security perspective, it's crucial to budget for protective measures such as firewalls, encryption, and intrusion detection. A cost-benefit analysis helps determine which model best meets your financial and security needs. Next, we have what is called responsiveness, and this refers to how quickly your system can adapt to changes or demands, which could be scaling up resources or responding to a cyber threat. So for example, cloud-based architectures allow for rapid scaling in response to demand, making it easier to address security threats that require increased compute resources. In on-premises systems, responsiveness might be slower since hardware and software updates take more time and involve manual interventions. Next, we have what is called scalability, and this is the capacity of an architecture to grow as the business expands. Cloud architectures are typically highly scalable and can handle increases in workload effortlessly. This scalability also benefits security as additional resources can be allocated to counteract DDoS attacks or support complex encryption algorithms. Now, on the flip side, scaling up an on-premises infrastructure requires additional hardware, which is both costly and time-consuming, potentially leaving your system vulnerable to emerging threats while you catch up. Next, let's talk about ease of deployment, which is a major consideration. So cloud models, they shine here, enabling rapid provisioning of resources with just a few clicks. And this ease also extends to security features such as automated patching and pre-configured security tools. For on-premises systems, deployment is slower and more complex, and each new server or service may require manual setup and security configurations, which can lead to delays and potential misconfigurations. Next, we have what is called risk transference, and this is when an organization shifts certain risks to a third party. So, for instance, using cloud services transfers some security risks to the cloud provider. They handle the security of the physical infrastructure, regular maintenance, and some aspects of data protection. With on-premises setups, your organization owns all of the risks, meaning you are responsible for the entire stack from physical security to software vulnerabilities. Next, we have what is called ease of recovery, and this focuses on how quickly a system can bounce back after an incident, such as a data breach or hardware failure. Cloud services typically provide easier recovery through features like automated backups and disaster recovery as a service. For on-premises systems, recovery processes can be labor-intensive, involving restoring data from tapes or off-site storage, reconfiguring systems, and potentially extended downtime. All right, next we have what is called patch availability and the inability to patch. So patch availability is crucial for addressing vulnerabilities. Cloud providers usually handle patching for the underlying infrastructure, but customers are responsible for patching their applications. In contrast, on-premises systems rely entirely on in-house teams for timely updates, and failure to patch can leave systems vulnerable. In some legacy systems or critical infrastructures, patches might not be available or feasible to apply, creating significant security challenges. Next, we have power considerations, and these can directly impact system availability and reliability. Cloud providers typically have power redundancy to ensure uninterrupted service. On-premises architectures, on the other hand, they require backup power sources like UPS or uninterruptible power supply systems and generators, which must be maintained and tested regularly. Next, we have what are called compute resources. So this refers to the processing power required to run applications and services. Cloud providers offer scalable compute resources on demand, which is advantageous for handling unexpected spikes in workload and for supporting compute-heavy security processes like encryption. On-premises systems, they are limited by the hardware capacity available on site, and this can pose challenges for supporting high compute demands without significant hardware investments. All right, so to sum all of this up, when comparing different architecture models, each comes with its own unique set of security implications: availability, resilience, cost, responsiveness, scalability, ease of deployment, risk transference, ease of recovery. Patch availability, power considerations, and compute resources are all critical factors. As an IT security professional or CompTIA Security Plus exam candidate, you need to understand how these considerations affect your security posture and overall architecture design.